Good morning, students. So today we are going to see about the method corrosion control, prevention of corrosion phenomenon by several techniques. So first of all, what is meant by corrosion? Corrosion is a natural phenomenon which deteriorates the metal. The environment affects the metallic piece. So slowly the metallic structure gets deteriorated. So we can prevent the metallic structure by selecting few techniques. Number one, by choosing the appropriate metal. So by selecting the metallic piece, we can prevent corrosion by using the pure metal. So usually, if any contamination is present on the metal, that may enhance for a galvanic corrosion. So we can prevent corrosion by choosing the pure metal. Usually pure metals do not undergo corrosion. Then by alloying techniques. So alloying means a combination of metal, non-metal, or combination of two metals. If we mix the two metals, or if we mix metal and a non-metal, that metallic property, corrosion property, can be protected. It is not undergoing corrosion. Then by means of choosing proper design. So proper design can avoid galvanic corrosion. Then if any bend or design is improper, means we can have some type of corrosion which may affect the metallic piece. So the structure should be plain. So by getting plain structure, we can avoid the corrosion. Then avoiding of sharp corners and bends. During making the article of the metallic structure, we can avoid sharp edges and bends, because the sharp edges and bends enhances the corrosion. Then avoiding of crevices. So crevice is a type of corrosion which is damaging the metallic piece. So by avoiding the crevice, we can prevent this corrosion type. The next one, the most important one, corrosion prevention by electrochemical protection method. So by using this electrochemical protection method or cathodic protection method, we can completely avoid the corrosion. Usually the ship, which is always in the marine system in its entire lifetime, but the ship is not getting corroded frequently. Now the ship is getting protected by means of this electrochemical protection method or cathodic protection method. This is the main method for the functioning of a ship or any marine vehicle without corrosion, because marine vehicles are requiring major cost. It is economically highly costliest vessels. So we have to save it. So by using this electrochemical protection method, we can save the marine vessels. So here under electrochemical protection method, we have two methods are given. One is sacrificial anode method, another one is impressed cathodic current method. In the number one, sacrificial anode method, the metallic piece which is acting as anode sacrifices its life. Anode totally sacrifices its life. So that anode material is undergoing corrosion. See here, the metallic piece is considered as underground pipeline. This pipeline is usually made up of iron. So usually we can expect corrosion on this underground pipeline. And it is buried in nature. So if any leakages occurs, means it is not easy to identify the leakages and it is difficult to repair it. So for that purpose, during installation time, that underground pipelines are connected with the more active metal zinc. Here the more active metal zinc is acting as anode. It is forced the underground pipeline metal iron to act as a cathode. So here the cathodic material is underground pipeline and the more active metal is zinc. So similar to zinc, we can connect magnesium and aluminum rods also. So by connecting this zinc with underground pipeline, all type of corrosion are concentrated on the more active metal zinc. Now, due to the corrosion undergone by this zinc, the underground pipeline iron material is protected. There is no corrosion is occurring on this pipeline because the full corrosion are concentrated on this zinc material because it is more active. So usually more active materials are most chances for occurring oxidation process. Oxidation process are nothing but corrosion. So here all the corrosions are occurring on the corrosion more active metal zinc. So due to the material zinc loses its life, sacrifices its life. So that is why we are giving the name sacrificial anode method. So instead of zinc, we can use aluminum, magnesium as sacrificial anodes. So this is the highly supportive method for protecting ship and boats. So usually ship are highly costliest vessels and its lifetime is also some decades it is functioning and it is always present in the marine water. Marine water is a saline water, so it enhances corrosion fastly. So ships are highly, we can expect corrosion most frequently on ship vessel. If it is undergoing any corrosion, then automatically water will intrude into the ship vessel, automatically it will go for zinking. So it may create an accident. So to avoid such a type of unwanted activities, that ship is connected with the magnesium rods or zinc rods. So magnesium rods or zinc rods are more active than iron. According to EMF series, the zinc is having negative electrode potential value. So zinc has negative electrode potential value means it is more active metal when compared to iron. So iron is acting as cathode, but the metal magnesium or zinc is acting as anode. So all the corrosion phenomena are concentrated on this newly connected metal zinc or magnesium. So this is getting deteriorated. The original nature of the zinc or magnesium gets damaged frequently. At the same time, it protects the ship vessel. Ship hull can be prevented by concentrating all the corrosion on the newly inserted material, magnesium or zinc. So due to the zinc material loses its life, sacrifices its life, we are calling this method as a sacrificial anode method. So one more example we can give here. Underground pipeline is connected with the same more active material. And here the boiler. So boiler is also more expected for corrosion because of saline water. Here also it is connected with the sacrificial anode method. Similarly, we can prevent underground pipelines cables from soil corrosion. Then domestic water boilers can be prevented from corrosion by inserting magnesium sheets. The next method in electrochemical methods, the second method giving its support is for prevention of corrosion is impressed current cathodic protection method. Impressed cathodic protection method. Here, the metallic structure which is going to be protected from corrosion is connected with the negative terminal of the battery. The metallic structure which is going to be prevented from corrosion is connected with the negative terminal of the battery. And the positive terminal may be inert anode. Usually here inert anodes are graphite or platinized titanium. So the metallic structure is connected with the negative terminal, that is and the positive cathode terminal, and the anode is here inert anode. The inert anode usually here give its support or graphite material and platinized titanium. Then the anode is buried in a backfill. The backfill is a mixture containing gypsum, coke, grease and sodium sulfate. Why backfill is taken? To get good electrical contact. To get good electrical contact, backfill is chosen. See, this is underground pipeline. This structure is going to be protected by cathodic current method. So the metallic structure is connected with the cathode terminal. The anode terminal usually it is inert anode. So the inert anode is here chosen is graphite. That graphite anode is buried in a backfill. Backfill is a mixture of gypsum, coke, grease and sodium sulfate. So why this backfill is attached here? To get good electrical contact. So by this method, if we supply electrical current to this circuit, automatically anode will undergo oxidation. Anode terminal will undergo oxidation. So usually according to electrochemical principles, the cathode will undergo reduction. So reduction means no corrosion. Anode means oxidation. Fully we can expect corrosion. So corrosion is highly concentrated on the anodic material. By preventing the cathodic materials are highly prevented from corrosion phenomenon. So we can be in the safer side because frequently we can change this anodic material. Within 2 months or 3 months we can change this anodic material. But at the same time, we don't worry about this corrosion on this cathodic terminal. It is always free from cathodic corrosion phenomenon. Similarly, this application of cathodic current method are highly supportive in prevention of corrosion in tank, pipelines, transmission line towers, underground water pipeline, oil pipeline. Ships can be protected by this method. See, these are all highly economically wise, large amount investment it requires. Underground pipeline, oil pipeline. If it is damaged, then its recovery is very difficult. We have to spend more money to recover the minor repairs. So instead of going for a damage, in the beginning itself, that material, the protection material, the material which has to be protected is connected with the more active metal. That is, we can choose either sacrificial anode or impressed voltage method to prevent corrosion. Thank you.